A simple pendulum of length 10 meters is released from horizontal position. Initially, it is in horizontal position. 10% of energy is lost. When it is in horizontal position, so the energy which it has is potential energy. When it reaches this, in general, loss of energy is equal to gain of kinetic energy. But in the given problem, 10% of energy is lost. When it is at position A, energy associated with the bob of mass m is mgh. When it reaches B, at B, it loses 10% of its energy. So, what is the energy now which associated with this at B? 10% it loses means energy now associated with this bob at B is 9 by 10 mgh. With that energy, it converted to kinetic energy. Half mv square is 9 by 10 of mgh. Get cancelled. He is asking velocity. So 9 by 5, g is 10, height is 10 meters. So it is nothing but 180. 36 into 5, v will be 6 root 5 meter per second. Here, two equal charges of masses m1 and m are sent in transverse magnetic field by accelerating through same potential difference. Find the ratio of their masses. Here, the standard question every time he is asking this. What is given is charge on both particles is same. This is first information. Here they are accelerated through same potential difference. So, but their masses are different. First particle having mass m1 v1, it attains velocity when you apply a voltage v. That is potential difference. Second charged particle that attains a velocity. Since both are having same charges, these two must be equal. So that means here I can say v square is nothing but 2qv by m. Now, once they sent in a magnetic field at right angles, that charged particle moves in a circular path. Force on a charged particle is qvb. That becomes a centripetal force, which is mv square by r. So this get cancelled. He is asking ratio of masses m equal to qbr by qbr by v. One. Here it is QB is equal to mv by r. Kinetic energy is half mv square, which is m square v square by 2m. So mv will be 2m times kinetic energy. That kinetic energy here is 2m times qv. Here qb becomes, in place of mv, I will write 2m qv by r. Here charge is same, both sent in same magnetic field. This is also same. And potential difference applied on charged particle is same. That means R is only proportional to the mass. So M is proportional to R square. So M1 by M2 is R1 square by R2 square. Here it is. A planet revolves around a sun within the radius R. The period of another planet which is at a distance R by 4 from the sun. So the relation between time period and radius. Radius means distance from center of the sun to center of planet. This is Kepler's law. So here it is T1 square by T2 square is R1 cube by R2 cube. So here first plan T1 square by T2 square is, first one is having R1, first one is R, second one radius is R by 4. So R cube 64 by R cube. So T1 by T2 is 8. T2 here is, so for a first planet it took 200 days. For second planet it will take only 25 days. So in YDSC experiment, I maximum is the intensity at central maximum. So here YDSC setup, two slits are separated by distance small d and screen is kept at a distance d, and monochromatic light is passed through both the splits, and here at the center there is no path difference. When path difference is 0, here we can observe a bright light which is known as central maximum. When there is a path difference, this is the path difference. That path difference is n lambda, we get another central bright fringe. But he given here it as path difference, he given for every path difference there is a phase difference. Phase difference is 2 pi by lambda times path difference, 2 pi by lambda into 7 lambda by 4, which is 7 pi by 2. So two waves of intensity I1 and I2, they interfere, then we get a maximum intensity I is equal to I1 plus I2 plus 2 root I1 I2 cos phi. So these are, if intensity of each wave is same, then we have 2I cos phi, which is This is resultant intensity 2I into 1 plus cos phi. So here it is 1 plus cos 7 pi by 2, that is phase difference, uh, which is 2R. Cos 270 is 630. Odd multiples of pi by 2 is 0. So then what he is asking, I by I maximum. So I here is I maximum is nothing but when phase difference is pi. I maximum we get when phase difference is 0, that is 2I plus 2I cos, that is 4I. Here it is 2I, 2I. So it is 2I by 4I, which we get half. Here, if n moles of triatomic gas and 2 moles of monatomic gas are mixed to give a mixture of 5 degrees of freedom. Fine. This is also standard model. When different moles of gas with different degree of freedom are mixed at a common temperature, means thermal equilibrium, then internal energy after mixing is equal to sum of internal energies of all gases. So internal energy is nothing but for one molecule, for 1 mole half RT, for n moles n by 2 RT, for 1 degree of freedom, for f degrees of freedom this. So here n1 may be having, here each molecule is having f1 degrees of freedom, here f2 degrees of freedom, like this. This is effective degrees of freedom. Here n1 n1 f1 RT by 2 plus n2 f2 by 2 RT, this one. So RT is everywhere, 2 also everywhere. N into F effective is equal to N1 F1 plus N2 F2 so on. Here N is nothing but sum of all moles of different gases. So that is F effective will be N1 F1 plus N2 F2 so on by N1 plus N2 so on. Now he given N moles of triatomic gas degrees of freedom he given, and 2 moles of monatomic gas 3 degrees of freedom by N1 plus N2. The mixture is having freedom 6n plus 6 is equal to 5n plus 10. Here you get n is equal to 4. 2 rods of same length and same material applied with the forces F and F by 2. If the cross-sectional area, one is having radius R, So this is radius r, it is r by 2. Then find the ratio of extension. Same material, Young's modulus is same. Young's modulus is stress by strain. F by A, delta L by L. Here, what he given is same length. So length is fixed. Applied forces are different. Here I will write FL, area is pi r square delta L. Whatever is same, let us not consider. Pi is constant. So here force changing, radius of cross section, area of cross section changes, radius changes. So if I denote delta L as with E is constant. F1 by R1 square E1, F2 by R2 square E2. F1 is F, R square, E1 is E, F2 applied force R square by 4, here E1. F get cancel, R square E get cancel, here it is R square by 4. That is R square E1 by 2 is R square E. That means E, here E1 is nothing but 2E. So E is to E1, that is 1 is to 2. A liquid drop of radius r is divided into 27 identical drops. So here, whatever the energy stored in the liquid drop, here some energy is spent on this to make it to 27 drops. If more number of drops are there, volume is constant, but there will be increment in surface area. So here surface tension force will do work to increase the surface area. That surface tension force, so work done by surface tension force is this. Initially, bigger drop is having radius r, smaller drop is having smaller. Here it is surface area of spherical one 4 pi r square. Now, how many such drops are there? 27 drops. Surface area of all these drops is this. Bigger drop surface area is this. So here relation between this volumes are same. 4 by 3 pi r cube is 27 times 4 by 3 pi r cube. 3r whole cube is r cube. So r cube will be from here, r is 3r. So here it is surface tension T, 4 pi common, 27 r square minus r square, which is 4 pi T. Here 3r in place of r, I will write capital R square by 9 minus r square. It is 2r square, so 8 pi r square T. This is the work done in this process. This is obvious question. Find velocity when acceleration is 0. So velocity is dx by dt. That is 3t square minus 12t plus 20. Acceleration dv by dt, which is 60 minus 12, when acceleration 0 happens when time is 2 seconds. At that time, we have to find velocity, which is 3 into 2 square, 12 into 2 plus 20. 32 minus 24, 8 meter per second. Here, this time he given two questions from elasticity. This is the second question. Two rods of same material, as I told you in earlier problem also, y is same. What else he given? Same. Volume also same. And areas in the ratio 4:1. So Young's modulus, basic definition, ratio of stress and strain, and F by A delta L by L. He told same extension. Whatever is same, we can remove it. So Young's volumes also same. Let us write here. F I will multiply with A. Delta L is volume. A square delta L is extension. Here extension same, volume same, same material, Young's modulus same. F is proportional to A square. F1 by F2 is A1 square by A2 square. That is 16 by 1. So F1 is to F2 is 16 is to 1. The period of the particle SHM is 6 pi. So the time period is 6 pi seconds. Find the time taken by the particle to go from x equal to a to x equal to a by 2. Here it is. This is mean position. It is extreme position. Here at extreme position, x is a. So what is the time taken from extreme position to the mean position? When particle starts from extreme position, we use a formula a cos omega t. Mean position a sine, extreme a cos omega t. When it comes to a by 2, it is from here to here a by 2, here to here also, always distances will be measured from mean position. Since it is midpoint, both will be same. Cos omega t here is half. Omega t is pi by 3, cos 60. Omega is 2 pi by capital T, which is pi by 3. Get cancelled. 2t 60 is equal to capital T, which he given it as 6 pi. So time taken to move from right extreme to middle is 5 seconds. Here, this for ideal gas, pressure is 1.38 atmospheres and number of molecules are less. So ideal gas equations, N here is number of moles. I can write this as N by Na, where N is number of molecules present in the gas, RT. And we know that here it is N into R by Na of T. R by Na is K, which is Boltzmann constant. So here it is N K T. So N he given it as 2 into 10 power 25. Boltzmann constant. Sorry, not N. This I can write it as P is equal to N by V K T. He given one number of molecules per unit volume. That means molecules per unit volume. That he given it as 2 into 10 power 25. Boltzmann constant value 1.38 into 10 power minus 23 temperature. 1.38, 2 into 1.38 into 10 square into T. So T here is, so 1 by 200. Here one atmospheric pressure. So that also one atmospheric pressure is 10 power 5 Newton per meter square. Here it is 10 power 5. So 10 power 5. This is 10 cube by 2, which is 500 Kelvin. So then average power, direct formula based question. So I naught V naught cos pi. Here it is 2. I naught here is 100. This is also like 100. Cos phase difference between this and this is pi by 3. And here current is milliamperes. This get cancelled. 10 by 5 into cos 60 of 2.5 watts. Here I naught means maximum current. That is I naught in the sense maximum current. 100 milliamperes. V naught means maximum voltage. A particle is tied to a rope. If it is moving it is just completes the vertical circle. Once it just completes vertical circle, the minimum velocity which we must give to complete vertical circle is root 5 gr. Then at this point it has a velocity root gr. Ratio of kinetic energy is half mva square is to half mvb square. Yes, get cancelled. Va is 5 gr is to gr. 5 is to 1. Here positive charge is present in the nucleus and electrons. This is Rutherford model. And plum pudding is a special case of positive as well as negative charges. That was Thomson model. So S1 is true, but S2 is false. Here it is in a single slit diffraction experiment. So diffraction experiment, third minima is obtained at that is y3 will be 3 lambda d by d. First minima will be lambda d by d. It's not uh, Young's double slit experiment, it is diffraction experiment. Young's double slit means third minima will be 3 lambda d by 2d. The difference between this will be 2 lambda d by d, which is 3 mm. This is, and he given lambda value 6,000 angstrom units, and what else he given? Capital D he given, lambda is 6,000 angstrom units. 1 angstrom unit 10 power minus 10 meters, that is 6 into 10 power minus 7 meters. Capital D, distance from slit and screen, centimeters, 50 by 100, half meter. Lambda is 6 into 10 power minus 7, half. Here, slit width only we have to find out, 3 into 10 power minus 3. Three twos get cancelled. 10 power minus 3, 10 power minus 4. D will be 2 into 10 power minus 4 centimeters. 10 power minus 4 into 10 cube mm. That is 2 into, we get 0.2 mm. Here it is